Yo, what's going on, guys? Welcome back to another video. This video is about, well, just a little big review of everything we covered this semester. Now, this review is great, especially because y'all have your post test coming up. So this will show everything that will really be covered on the post test. Um, you do need to know some vocab. So I won't read everything here on this screen. Well, actually, this screen is not that bad. The next screen is has a lot of words. But we discussed qualitative data and quantitative data. So remember, qualitative, it was descriptive data. So it was thinking of as just different types of adjectives, as opposed to quantitative data, it was numerical data. I made that statement of like I care more about the quantity of pizza than the quality of pizza. I care more about the quantitative part of it than the quality part. That's why I may go to Little Caesar sometimes. So more vocab. We just learned different ways to display data. The three ways we covered this semester were pie chart, bar chart, and a box plot. Not going to read all of that. You can pause the screen if you like, or you just look back through your notes. That's where I just got all these definitions from. Perfect. So let's make sure we know how to calculate relative frequency. So there's just this example I pulled. The Rocky Mountain Beverage Company wants feedback on its new product, wow, I can't speak. That's funny. Coro Cola, and sets up a taste test with 20 people. Each individual is asked to rate the taste of the cola on a 5-point scale. So one being bad taste, five being excellent taste. As you can see, all these numbers vary. So let's calculate the relative frequency here. Now, I gave you the frequency counts here. Maybe you need to do it yourself. Either way, we just saw that, hey, that there was two people who said it had a taste scale of 1, 3 who had a taste scale of 2, 9 had a taste scale of 3, so on and so forth. So when calculating relative frequency, and what I'll do is actually I'll just make it right here, like a little, just an extra column. Perfect, I can spell, can't I? Let me move one person out of the way. So when calculating relative frequency, you need to make sure you have the frequency counts, and need to make sure, perfect, you have the total as well. So right here, they already gave us a total. That was nice. Um, the relative frequency, remember, is just kind of like the part over the whole. It's a percentage of whatever category compared to the rest. So to find relative frequency, we're just going to take each frequency counts and divide them by the total. So each counts and divide it by the total, 9 over 20, 4 over 20, and then 2 over 20. Now, luckily I have a calculator here, which some of these I should know. So I'm going to go ahead and write it as decimal, and then I'll go ahead and write it as a percentage. Right, so I calculated all the relative frequencies for here, and notice I did put decimals. Doesn't really matter what you do. I know in class we've been doing percentages, so I'll make sure to put these in percentage. Um, you multiply each number by 100, or just move the decimal place over. But in this case here, 0.1 is the same thing as 10%. My bad. 0.15 is the same thing as 15%. We have 45%. We got 20%. And then we got 10%. Beautiful, amazing, I know. So make sure you know how to calculate relative frequency. Um, we're not going to talk about two-way tables, so don't worry about that. We did like one example, but we are going to talk about box plots, something we talked about. Okay, so box plots. How do we calculate all the stuff? Well, remember, box plots is just displaying different patterns in data, and mainly it covers 5 numbers. So I just made up this random set. Nothing too crazy about it or special about it. There's not even a scenario with it. I'm going to find these 5 numbers being the min, median, max, quartile 1, and quartile 3. So the min, median, and max, nothing too crazy about those. You've known that since, man, sometime in middle school. The min is our smallest number. Let me get a different color. The min is going to be our smallest number. and the max is going to be our biggest number. In this case, again, I gave you the numbers already from least to greatest, so nothing to worry about right there. And then the median is going to be the middle number. Different ways to calculate this. If you see in this case, they're all odd, so you can divide it by 2 and just go from there, or just literally mark it off. So 1 by 1, 1 by 1, and just go like that. Boom. I think I miscounted 1, 3, 6, 3. Yeah, I missed one. Perfect. Awesome. There we go. So we have a median here of 50. Now to find quartile 1 and quartile 3, I'm going to take this data set, this whole data set, and I'm going to split it up into 2 separate pieces. One piece, and I'm move this over here. One piece is going to be to the left of the median, and the other piece is going to be to the right of the median. So with this here, that piece to the left of the median, that's going to help me find my quartile 1. So I just took that data set right there. So notice here, we have 7 points. And so quartile 1 is going to be the median of that data set. So if I want to, again, to do the same thing here, boom, boom, and you'll get that 48. Sorry, 48, 46. And we're going to do the same thing for quartile 3. Again, I just took the numbers that were to the right of our original median, and then just mark them off, and you'll see that 56 will be your third quartile. So we're not going to graph or box plot just yet. Remember, you need to make sure you check for outliers. And while looking at this data, you can kind of give it a little feel for which ones are outliers, right? Because looking through all this, these are on the 40s, these are on the 50s. That 75 is a little bit suspect because it's kind of far away from 58. But that 102 definitely suspect, and that 5 is definitely a suspect. If it diverges greatly from all the data, that means it's going to be an outlier. So there is a hard rule to figure out which ones are outliers and which ones might not be. First, we need to find the IQR. Again, IQR is the interquartile range. That is just the range, so the difference between RQ3 and RQ1. So there's 2 different ways to find outliers. Well, one way with 2 different numbers. We're going to calculate our quartile 1 minus 1.5 times our interquartile range. Any number lower than that, that's going to be considered an outlier. And on the other end of the spectrum, quartile 3 plus 1.5 times our IQR. Any number bigger than that or greater is an outlier. So with our data set here, we have quartile 1 is 46, quartile 3 is 56. So I'll just calculate on the side here. Our first part here, Q1 minus 1.5. Oh, my bad. I probably should calculate the IQR, right? The IQR is going to be our Q3 minus our Q1, which would be 56 minus 46, which is 10. Now, each of these points here, Q1 minus 1.5 times our IQR. So Q1 we know was 46, and our IQR was 10. Again, I'll just use a calculator for this part. And so it looks like Q1 minus 1.5 times RQR, it will be perfect, 31. So we'll discuss what that means in a bit. And then Q3 plus 1.5 times our IQR. Well, we know that Q3 is 56. We know that our IQR is 10. Therefore, this says that any number bigger than 71 is going to be an outlier. So looking at our data set right here, we know that any number smaller than 31 will be an outlier. That means that 5 is going to be an outlier. And any number bigger than 71 is an outlier. So we got 75 and 102, which were the numbers we suspected in the first place. We're like, those seem kind of suspect a little bit. And it's true, they were suspect. So when making a box plot, again, we need these 5 numbers. And then from there, we're going to evaluate our box plot. Yeah, we're fine. Okay. Excuse me. So our median here is going to be 50. Our max, well, actually, let's do a quartile 1 of quartile 3. Our quartile 1 and quartile 3 is going to be 46 and 56. Just try your best here. This is not the best graph, but we just had a lot of data. Q3 is 56. So there's our box. Remember, this is sometimes called the box and whisker plot. The reason why is for this next part. We had an outlier at, I'll make sure to write this down, 75 and 102. So 575 and 102. So notice we would normally start to extend our whiskers from the box to our smallest point that is not an outlier. In this case, 5 is an outlier, so we need to find the next point that is not. That means 40. We're going to extend our whiskers to 40. Okay? So in this case, I'm going to extend my whiskers to 40 and put a dot at 5. Excuse me. All of our outliers are represented by dots. And same thing here on the other end. Since these two numbers are outliers, are big on the greater end, that means 58 is going to be our biggest number that is not an outlier. So I'll extend my whiskers to 58, which is not a lot because it's just, and that's like almost at 59 right there. And then we'll place 2 dots at 75 and 102. So, excuse me. One thing to remember, I'll do this in a different color. All right, Q2 is at the median. Q1 is right here. Q3 is right here. We're going to extend our whiskers to the smallest non-outlier and to the greatest non-outlier. For all of our outliers that we get by using our IQ rule of IQR, our rule of outliers, we're going to place a dot on our box plot. Make sure to put a scale just because it's nice to know. And then from there, we'll be able to make our box plot. One thing to remember, this has 25% of the data. This has 25% of data, which means that basically, I'm not sure what scenario this would be, but 25% of our data is in between quartile 1 and quartile 2. 25 is between quartile 2, and quartile 3. Excuse me. And then this also means something, and I probably should have mentioned this in class. I just kind of jumped the gun on the box and whisker plots. This right here, since we have outliers, since we have outliers, I'll emphasize that one more time. Since we have outliers, this right here is technically 24.65. Yeah, 24.65% of our data. So that is going into a thing called a normal distribution of a probability distribution graph. We have not talked about that, and we really just haven't. Well, we're not going to discuss that because we're out of time, but you will discuss that this semester. That being said, if we don't have outliers, from our Q1 to our other whisker is 25%, and our Q3 to other whisker is 25%. If you do have outliers, technically the outliers do consist of some data. I made that mistake during class, and I apologize. Man, excuse me, I'm coughing a lot. I think that was, yeah, wow, perfect. That's a lot better than mine. But if you have any questions, you have my email address, you have my Canvas message, you have my Canvas inbox. Um, If you have any questions about anything, please let me know. I'm excited for class on Tuesday. I will see y'all then.